Hello class, today we're going to be talking about parallel and perpendicular lines. So to start off, let's get a couple of definitions. Parallel lines are simply two lines in a plane that do not intersect. So these might be something like this. Okay, look like the railroad tracks. They could be at various angles. Okay, they could be both vertical if need be. So those would be parallel lines. And you know the old math joke, parallel lines are the saddest story in the world because they have so much in common, but they never meet. So anyway, perpendicular lines would then be two lines in a plane that intersect at a right angle. And of course, you should be familiar with those. They look something like this, okay? Where the angle in between is a right angle. That little box symbol there shows that it is a right angle, a 90-degree angle. Okay, those would be your perpendicular lines. There's a special relationship between the slopes of lines that are parallel and lines that are perpendicular. Okay? Parallel lines have slopes that are the same. Okay? So if a line has a slope of 3, a line parallel to it would also have a slope of 3. Perpendicular lines have slopes that are negative reciprocals. Big word there. I'll talk about what that means. Okay, to find a negative reciprocal, we're going to change the sign of the slope. So if it's positive, it's going to become negative. Okay, and we're also going to flip the fraction. Okay, so remember, if a slope is an integer like 2 or 3 or -6, to make it a fraction you're simply going to make that 2 over 1, 3 over 1, -6 over 1. Okay, so to make it a fraction, remember, just going to put it over 1. To find the negative reciprocal, you're going to change the sign. If it's positive, it's going to be negative. If it's negative, it's going to become positive. Then you're going to flip that fraction. Okay? Okay, let's take a look at some examples here. Here we have a table. We're going to complete the table with slopes of lines that are parallel and perpendicular to the original slope. So you can see here we've got our original slopes in this column. Okay? These are all our original slopes. And we're going to find the slope of a parallel line and a slope of a perpendicular line. So let's get started. Let's get started with the parallel slopes. Those are pretty straightforward. Okay? Because remember, parallel slopes are identical. They're the same. So if my original line has a slope of 3, my parallel line is also going to have a slope of 3. My original line has a slope of -4. My parallel line is going to have a slope of -4. My original slope is 1/3. My parallel line is going to have a slope of, well, 1/3. My original line has a slope of -3/2. My parallel slope is going to be -3/2. My original slope has a slope of 0. My parallel slope will also have a slope of 0. And my undefined slope, well, my parallel line would also be undefined. Okay, now the perpendicular slopes. Remember, we're going to change the sign and we're going to flip the fraction. So here, for the first one, I've got a slope of +3. My perpendicular slope would be -1/3. Okay, Slope of negative 4. Well, my perpendicular slope would be positive 1 over 4. A slope of positive 1/3. Well, perpendicular is going to be negative 3 over 1, or simply negative 3. Slope of negative 3 over 2. Perpendicular is going to be positive 2 over 3. Now let's talk about these last two here for a moment. I've got slopes of 0 and undefined. 0 and undefined. Let's take a closer look at those. You're not going to see any space for this. You may want to jot this down someplace on your note sheet. If I have a slope that has a line that has a slope of 0, that looks like this. Okay? 0 slope. Okay? If I have my line that with an undefined slope, that looks like this. Okay? These are a couple of special instances because the 0 slope line and the undefined slope line, those are perpendicular. Okay? They meet at right angles. Okay, remember, the undefined is vertical. It runs straight up and down here. Okay, and the 0 slope is horizontal. And so by definition, the line that is perpendicular to a 0 slope is undefined, and the line that is perpendicular undefined is 0. So let's go back to our chart. Okay, so coming back to our chart here, if I have a line with 0 slope, my perpendicular slope would then be undefined. And my undefined slope is going to have a perpendicular slope of 0. Okay? So if you're given a table like this, you should be able to go through and fill out the slopes for lines that are perpendicular and parallel to a given slope. Okay, another thing you're going to be asked to do, if I give you a line, I want you to write an equation for a line parallel and perpendicular to that given line. So here we're given y equals 3x plus 2. So if I'm looking at that right here, I'm already in my slope-intercept form. So I know that my slope here equals 3. Okay? Now remember, a parallel line is going to have that same slope. So to find an equation with that same slope, I'm simply going to write y equals 3x. And it doesn't matter what I have for a y-intercept. I could have plus 6, and that would be fine. I could have y equals 3x minus 2. I could have y equals 3x plus 143,798. Those would all be parallel lines to it. Okay? Now, getting over here to the perpendicular side, that's a little bit different. Okay? Because my slope perpendicular here is going to be, change the sign. Okay, remember this is the same thing as 3 over 1. I'm going to change that to a negative, and it's going to be 1 over 3. Now, to go ahead and find equations of lines that are perpendicular to our original line, it's going to be y equals negative 1/3 x, and again, it doesn't matter what my y-intercept is. Okay, could be 7. Okay, and I could have a bunch of lines here. I could say y equals, as long as I have the same slope here, negative 1/3 x minus 12. Again, it doesn't matter what my y-intercept is. As long as I have the correct slope, I'm going to be fine. Let's take a look at another example. Okay, taking a look at this example. We have 2x plus 3y equals 9. Well, right off the bat, one of the problems we see here is because we're not in slope-intercept form, we don't know what our slope is immediately just by looking at it. So first we need to find our slope. Okay? So I'm going to go ahead and try to find 2 points that are on this line. Okay, I'm going to have my little table here. X, Y. Okay, I look at this. I'm going to plug in 0 for X. So I know that 2 times 0 plus 3Y equals 9. Okay, that cancels out. 3Y equals 9. Divide both sides by 3. I can see that Y equals 3. Okay, so I have 1 point right there at 0, 3. I'm going to go ahead, I'm going to plug in, let's say I plug in 1 for Y. I'll plug in 1 for Y. So I have 2x plus 3 times 1 equals 9. Okay, so I have 2x plus 3 equals 9. Subtract 3, both sides. 2x equals 6. Divide both sides by 2. And I'm left with x equals 3. Okay, so I have my 2 points. I'm going to find my slope now. Remember, it's going to be y2 minus y1 over x2 minus x1. So I have slope equals 3 minus 1 over 0 minus 3. 3 minus 1 is 2. 0 minus 3, negative 3. So I'm left here with a slope of negative 2/3. Fantastic. Well, now I'm straightforward to find a line that is parallel. My parallel line is simply going to be y equals negative 2/3 x plus some y-intercept. Okay, let's use 9 for instance. Okay. Similarly, now I can go ahead and find my perpendicular. Okay, I know my slope perpendicular is going to be, I'm going to change the sign, so it's going to go from negative to positive, and I want 3 over 2. 3 over 2. Now write my equation for the line. Y equals 3 over 2 x. I'm going to add, I don't know, maybe 17. Okay? If I'm not given a point, if it's just any line that's parallel or any line perpendicular, it doesn't really matter what you use for your y-intercept. Okay, hope you're listening carefully for this and you got the correct answer. I will see you in class if you have any questions. Thank you.